SOLIDWORKS MBD provides an integrated, drawingless manufacturing solution which helps you define, organize, and publish 3D product manufacturing information along with 3D model data into industry-specific standard file formats. Manufacturing complex components with precise fits can be a multifaceted and time-consuming process. Creating drawings takes time, but communicating your design intent clearly and maintaining detailed multi-sheet drawings is even more challenging. SOLIDWORKS MBD lets you apply your manufacturing information directly to the model, making it easier to define, but also easier to understand. In an assembly like this underwater camera housing, where precise fits are required to prevent water ingress, and also where these gears need to mesh accurately to control zoom and focus, every part needs to be machined to very tight tolerances. This can mean high costs, but carefully considered geometric dimensioning and tolerancing can lower costs in some cases. So GD&T is not just for close tolerance parts and assemblies, it can also be applied to any part. The process of setting up a fully detailed 3D model is straightforward, starting with considering how a part is assembled. This blue gear plate is mounted on the base plate using these two bolts. With this in mind, the gear plate needs to be dimensioned in such a way as to ensure that the gears mesh correctly and the whole assembly works as expected. Taking a look at the gear plate itself, you can see that a couple of 3D views have been set up in advance. This 3D view is set up to show a set of notes that you may have found previously in a title block of a 2D drawing. You can easily bring in standard notes from a text file or from the design library. Rather than just being dumb text, you can easily link information such as material into the note just by selecting it from a convenient drop-down list. This makes these 3D notes accurate and up-to-date, reducing the chance of errors. The first step in detailing this part is to determine where the manufacturing datums are going to be. As the part is bolted to the base plate, this bottom surface will be the primary datum. This bearing bore controls the position of the shaft assembly, so that is going to be the second datum. The gear shaft is the tertiary datum, and this can be defined as a continuous hole as it's drilled in more than one operation. We could let SOLIDWORKS dimension all the features in this part, but we only need a few critical dimensions. You can now select which features to auto-dimension, so let's pick the mounting holes. These are automatically recognized as a pattern, and will also select the rear bearing hole. SOLIDWORKS does all the hard work for you and has automatically created the datums, dimensions, and geometric tolerances for the features selected. Those features are now fully defined as seen by the green color on the surfaces. Double-clicking on this dimension brings us to a top view, and we can see that the mounting holes have been recognized as a pattern, but it's missing its position. We can easily add this missing position by recreating the basic dimensions. All the information needed for these mounting holes is complete, so you can snapshot this as a 3D view. You can include annotations from other views as well, but we just need to capture what we can see here. There are several options when publishing this content, including PDF, eDrawings, and also Step 242, which now include PMI data natively. If we take a look at the template editor, it's been updated for 2017 to make it easier and more intuitive to create your required standards. Here you can see a complete published PDF of the gear plate with interactive 3D views containing all the PMI info that we defined in SOLIDWORKS. All of our views come across in the position that we defined, and if the user reviewing the document needs more information or things don't make sense, they can rotate or zoom in, and if a dimension or datum is selected, the faces of the model will highlight, showing exactly the geometry described in the annotation.